I'm working as an assistant professor in Rajagiri School of Engineering and Technology. I, along with Roni Anthony and Karnagaran P. Manon, will be taking the subject microprocessors and microcontrollers for the fifth semester Electronics and Communication branch. The course code is EC305. So this session is basically intended as an introduction to this particular subject, which is titled as microprocessors and microcontrollers. So I will be dealing with two things here in this particular session. One is the syllabus and the second one is the course information sheet associated with this particular subject. Now and I will also discuss a little bit about the basics of microprocessors and microcontrollers. So this will provide an introduction into this particular course, and this will be followed by corresponding video sessions in the format of PPT plus audio or as videos by Roni Anthony sir, Karun sir, and myself for the rest of the modules. So this will act as an introductory session for the further sessions which will be there. So we'll straight away move into the description of the syllabus. So microprocessors and microcontrollers is a subject which is based on the logic circuit design subject which was studied in your third semester. So you already are familiar with the logic circuit. So microprocessors and microcontrollers are basically an advanced version of a logic circuit which can do certain processing and controlling tasks. So that's the idea of microprocessors and microcontrollers. Okay. So when you look into the syllabus, which are the microprocessors and microcontrollers which we will be studying as part of this particular syllabus? So we'll move on to the syllabus details. So as you can see, 8085 is the particular microprocessor that is going to be studied as part of this particular syllabus. There is also certain inputs or certain descriptions of the 8086 processor and the comparisons between 8086, 80286, 80386, 80486, and even the Pentium processor. But it all sticks to the Intel-based processors. Okay, so the major microprocessor, which you will be studying, the number will be 8085, which is basically a Intel-based, Intel company-based processor. And the microcontroller that you're going to study will be 8051. Again, it has different companies which are coming out, which have their own microcontrollers based on 8051. Again, the first one is generally considered to be proposed from Intel. So you have 8085 as the microprocessor and 8051 as a microcontroller. So these are the two major modules or processor or controllers which will be focused in this particular syllabus. Now, moving along. So when you speak about the textbook, so expected outcomes of this particular syllabus will be to understand the architectures of processors, to understand the working of 8085 and 8051, memory organization of it, the programming of it, the assembly language programming, with again with the interfacing of peripherals with 8051. These are the major outcomes which are expected out of a student once he completes this particular course. So that's the orientation of this particular syllabus. So you have 8085 as a microprocessor and 8051 as a microcontroller. We will delve in detail about these particular ICs when you move into the corresponding modules. Now the three textbooks which are being focused here, one is based on your 8085 and the other one in 8051, and the third one a generic one which has both microprocessors and microcontrollers. So Ayala, Kenneth J. Ayala will be your 8051 microcontroller textbook. 8085 microprocessor textbook will be from Ramesh S. Goenka. Both these are very generic textbooks commonly used by students, very good textbooks to read, very good textbooks to understand the basic concepts of microprocessors and microcontrollers. The third textbook is a combination, textbook by Laila B. Das. She's a lecturer in NIT Calicut, Kerala. She's one of the pioneers in microprocessors and microcontrollers in Kerala, and her textbook titled Microprocessors and Microcontrollers, which basically gives you an idea about both these particular things with different examples of microprocessors and microcontrollers. So these are the three textbooks which are mainly used in this particular syllabus. There are other good textbook from other audios, like Mazidi is again a very good textbook. Again, Nagurkani based textbook, a very simple textbook. Mazidi is a standard textbook among the references which I made. So there are other references as well which can be looked upon for further reference. So these are the major topics with respect to the syllabus of microprocessors and microcontrollers. Okay. Now moving along, so we'll speak about the different modules here. Now in module 1, it's completely about microprocessors, which is your 8085, the pin configurations and other things, everything related to your 8085. Module 2, again the continuation of it with peripheral ICs and the programming, the development tools which are used, machine cycles, again sticking to the microprocessor domain. So that's your 8085. Module 3, you will be introduced with a more advanced version of a microprocessor, that's your 8086, and the comparisons between the different types of microprocessors. Then module 3, the second part deals with the microcontrollers. So you start out with the microcontrollers, move on to 8051, the particular microcontroller that you are studying. Module 4 speaks about the instruction sets, the addressing modes, the assembly language of 8051. So that's fully based on 8051. Even module 5 again speaks about the 8051 interfacing, the serial communication, the counter programming, the interrupts, everything will be described and explained and studied in your 5th module. In module 6, you will have interfacing. How do you interface your 8051 microcontroller with other modules like switches, motors, DACs, ADCs, LEDs, 7-segment displays and all. So that's the major topic in module 6. So this is the way in which your syllabus is arranged. So you have microprocessors, microcontrollers, interfacing, certain advanced microprocessors. These are the topics which will be covered as part of this particular syllabus. Now, with respect to the question paper, it's basically a theoretical subject. 80% of it is theory, 20% will be the programming and your logical and numerical problems. Rather than the logical and numerical problems, major focus will be on the programming part in the second part of your syllabus. So out of the 20% of your syllabus, it's mainly into the programming. So that's the general overview of your syllabus. So microprocessor that we learn is 8085 and the microcontroller that we learn is 8051. Okay. So now we will move on to the the CIS of your particular thing. So I will just show you the CIS, and then we will explain the CIS part. Okay. Sorry. Okay, so course information sheet is basically something which is used to give the information regarding this particular course. What are the outcomes, the program outcomes which are expected, the program specific ESO outputs, how you relate it and all. So I'll just brief you through the CIS of this particular subject, that is your microprocessors and microcontrollers, and finally I will end with a general overview of what a microprocessor is and what a microcontroller is. Okay, so the first part of the CIS is basically the description of the syllabus itself, the number of hours which are used. We already seen the syllabus in detail. So the syllabus again being written here with respect to hours. Again, the next part is discussing about the references and your textbooks, again discussed as part of your syllabus. Now, prerequisite, I told you, logic circuit design. Again, computer organization had certain, we had learned about an architecture called as MIPS in your computer organization. But again, it was not focused on a processor, it was focused on an architecture. So that's the difference when it comes to microprocessors and microcontrollers subject. So it doesn't become a prerequisite. Logic circuit design, which is a lower version of a digital circuit, becomes a prerequisite for this, for the understanding of how these microprocessors and microcontrollers are built. Now, course objectives, fundamental concept of microprocessors and microcontrollers, communication between devices and controller, to program the controller, to design a microcontroller-based system. All these becomes the course objectives. Course outcomes, will be able to understand the processor and the controller architecture, assembly language programming of microprocessor, design a system, then interfacing of 8051. This will be help you in doing microcontroller based. So this is basically the outcomes which are expected out of this particular subject. So these are the course outcomes which are expected, which you should be gaining once you complete this particular subject. So this is your course outcome, program outcome, PSO mapping. PSO is program specific outcomes. So how do you relate these course outcomes, the 5 course outcomes, with various POs and PSOs which are generic, is being explained here. So justification for that is being described in the further things which you can go through and understand, just to make you aware that these are the things which we are trying to teach you. These are the things which you should gain once you complete this particular course. So all those things are there. Then there is no labs which are included in the current semester, but I guess there is a lab associated with this in the next semester. So you don't have this particular case of subject being studied and the lab being parallelly done. So both these things are independent. So that's one of the bad effects. So we will try to make it, aid it by giving you assignments based on certain tools, and we will try to introduce you to online tools which are available, on which you will be able to do your programming. So this has that particular thing lacking in the syllabus. Okay. So topic beyond the syllabus which we are trying to take will be the KIL-C based programming of your 8085 and your 8051. It's basically C programming for microcontrollers and microprocessors. According to the time obtained, we will try to do this. We will anyway try to do this. If more time is available, we will move on to other more generic tools which can be used as part of your study. So these are some of the web sources which are available. The methods will be assignments, delivery methods. Chalk and talk is something which is gone out of the picture currently, but again we will be using the online modules, online modes of communication for doing the particular class. Assessments will remain as such. We will have some kind of a viva, some practical sessions, some projects which will be done based on this, so that you will have a feel of things which are going to things which will help you in doing your design project and all. Okay. So since design project is involved in this particular semester, this will help you in doing such kind of a project. So this is the general idea about your syllabus and your course information sheet for the subject microprocessors and microcontrollers. So I will stop with a general overview of what a processor is and what a controller is. I had already taken this particular topic in my previous classes when in computer organization, but I will look into it in this particular context. So as we can see, the two keywords micro remain the same. That means it's a small thing. It is in the micro level. Physical size is what is being mentioned here. And the difference here is in processor and controller keywords. Now processor basically implies it will be processing data. Processing data implies that it will be focused on the ALU. The ALU will be powerful enough to handle more bits of data, and it will be powerful enough to do lots of arithmetic and non-arithmetic logical operations. So focus is on processing of data, taking the data from the memory, processing it, getting the output, putting it back into the memory. That is the focus of your microprocessor. It always interacts with the memory. Whereas when it comes to microcontroller, it is focused on controlling things. That means it has to control certain parameters. Control certain outputs based on the input signals. So it will have modules which will be used to communicate with the outside world. You will have analog to digital modules. You will have digital to analog modules inbuilt in it, outside it. It is not at all focused on interacting with your memory alone. It is also focused on interacting with other output input devices like switches, like LEDs, like motors and all. So the orientation of a microcontroller design is for controlling. It will also have an ALU, but the focus here is on controlling things, the number of ports, bitwise control, bytewise control, again different kinds of inputs and outputs, analog and digital inputs and outputs. So these are the things which are oriented in a microcontroller, and microcontroller will have more modules compared to a microprocessor which is focused on processing. Microcontroller will have timer modules, as I told you, ADC modules, DAC modules, lots of things inside it which will help in building a particular system. Microprocessor is something which can be concentrated for processing rather than building of a system. You need additional things to make a microprocessor into a system. Whereas microcontroller in itself has lots of components which can make it an ideal choice for building a particular system which can control certain activities. So most of the projects, most of the mini projects that you will be seeing and design projects usually be using microcontrollers. So this is the major difference. So there are a lot of theoretical differences, but this is the major difference with respect to a microprocessors and microcontrollers. Microprocessors focus on processing, whereas microcontroller focus on controlling things. Automatically, whatever choices that you make will be based on these two key points. So the further details you will be able to understand when you go down the syllabus and when you move along with the syllabus. So I guess this concludes the introduction session. I given a brief overview of the syllabus of the CIS and what a microprocessor and microcontroller is and what it is generally used for. So I'm stopping the session here, and best of luck for your S5 semester and for this particular subject. Thank you.